Hi everyone, thank you for joining us. We are going to get started. So today we're going to be talking about You Can Do That? Our special automation webinar. We get that question quite a bit from some of our customers when we describe some of the custom automation techniques that we're able to do. They seem surprised. So we're going to talk about lots of different types of automation that is possible and how we can help you come up with different types of automation that would work for your application and best for your business. The presenters today are Bob Bensingle and Rodney Leversey, and they both work in our Manufacturing Solutions Center. And I'll hand it over to them in just a second, but for right now, I want to quick point out that there is a Q&A portion. So you can, the panel should be open on the right side of your screen, but if it's not, there's a little, what looks like a chat emoji with a question mark inside of it, and you can click on that, and there's a place for you to type in your name and then also type in a question or a comment and then send those our way. And so just to make sure that that is working for everybody and to test that out, if you could just type in what you're hoping to get out of the webinar today. What do you hope to learn, and maybe where you're from, and send those our way, and we'll see those, and hopefully we can make sure that we address all of those things as we go forward. So without further ado, Bob, take it away.
All right, good morning, everyone. As Jason said, I am Bob Bensingle. I and Rodney both work in the Manufacturing Solutions Center. What that is exactly is we are a group that works closely with our customers to try to come up with concepts that meet your needs. Whether your needs are established through assembly technique or a budget or cycle time or operators or part requirements, we develop concepts and quotes that will provide the equipment that you are in need of. So what we do here at Extol, we improve the way plastic products are made. We work with you with plastic products, provide solutions across your value stream, and we partner with you to solve challenges. Some of the innovative technologies that we are known for here at Extol involve our InfraStake, which is for a staking process, an IR staking process. We do NanoStake, which is a low current, high performance closed loop staking system. We also do hot plate welding with our rapid conductors. We do hybrid vibration welding, which is basically doing an IR type of pre-treatment prior to vibration welding to minimize particulate. We do vortex spin welding. We do infra weld, which is through transmission IR welding. We also do laser welding for plastic welding. And we also have an IR welding, non-contact IR welding called the Infra Guide. Some of the services that we offer here at Extol involve the Process Development Center, where you can send products in and we can actually do testing on parts to establish what is the best joining method for your plastic application, as well as we can help you with design of the part for each of these different concepts. The other center is the Manufacturing Solutions Center, which we talked about earlier. We kind of help with the quoting, the concepting, and getting you the right quote for what you are in need of. We also have a digital development center, which does 3D printing of parts, can also do 3D printing of nesting, soft touch tooling, end of arms. And then also we have a technical support and service center, which would service the products that we sell, as well as provide spare parts. So how can Extol support you through your value stream? Up front, when it comes to the design and part verification, we can help with educating you on the type of designs necessary for each of the different technologies. Utilizing our Process Development Center, the Manufacturing Solutions Center can also help with the concepting of, hey, we think this is how the equipment should be laid out, how the parts should flow, whether it's completely manual or automated. And then going into the equipment where you're actually decided on this is the piece of equipment we want, and going from there, the Manufacturing Solutions Center would put together a quote for you, which could be a turnkey equipment, could be technology integration package, as well as at that point, once you issue a PO, the project team becomes involved at that point. And then once we roll it into production, Extol supports you through service and support and operator training, as well as spare parts through our service department. And now I'm going to pass it over to Rodney to go through the custom automation side.
Thank you, Bob and Jason. Good morning, everybody. So as Bob was mentioning, we have a lot of technologies that most of you probably know us for, but we've actually been doing custom automation since 1985, which is actually longer than any of the technologies. So a lot of people, like Jason was saying, say, you can do that? And we say, yes, we can. And we have a lot of experience with it. So there's a lot of different ways you can implement automation, a lot of different techniques for automation. And here's a lot of the common ones that we see. And I just wanted to go through all these and show you a few examples and maybe some reasons why you would implement something like that. So first is manually loaded machines. So this is when you have a low capital budget initially, so you don't want to put in a decent amount of investment up front. You have operators to use, and you have a low volume product. It's going to give you the most cost effectiveness up front, but you're going to be paying operators to run the machine, right? To put in the part and take out the part every cycle. So cost effective, but it's only if you have low volumes and have an operator to be able to use, right? So here's a couple larger machines. The top left one is for reference is a front panel for a semi truck. So it's a pretty large machine, and that one actually tilted down and had some infrastake modules combining those components together. On the top right, you have a door panel machine that had a shuttle towards the back for an infrastake module or infrastake process as well. And then to help out with the cost effectiveness down the road, you can also implement interchangeable tooling. And that's shown below. And you can do this with a manual cell, but you can also do it with, different types of automation that we'll get into later. But just know that you can use those and save a little bit of money in the future if you can put other parts into it with a similar process. So going into a different automation technique, this is really used when you don't want the operator moving the parts. You have multiple processes that you don't want the operator moving the parts in and out of machines for. So that's when we get to palletized conveying and dial indexing. And the difference between palletized conveying and dial indexing is pretty simple. Palletized conveying is a linear motion. You're conveying the part down with pallets down the line, and you're doing operations as you go down. Dial indexing is rotating the part around in a circle to each of its stations. Now, palletized conveying usually is used for more stations. If there's a lot more stations, usually you won't be able to fit it into a dial, or your dial will be fairly large unless you have a pretty small part. So that's used for mainly larger lines with excessive amounts of stations. And you can see up there on the top an assembly line that was used conveying. The one downfall would be that you're not able to use vacuum or air or sensors on the pallet, because that pallet has to ride on the conveyor and is able to be taken off. For the rotary indexing, you can use pneumatics and sensors, so that's a adder if you need that on your automation equipment. And usually it's a little bit more cost effective as long as you keep the dial within reason with not too many stations. And you can see a couple examples down there below. The left-hand example is a headlamp reflector assembly line or assembly indexer. And then the right hand is just a C-pillar infrastake dial indexer that had 2 operators on it. So you can add, you can have 1 operator, 2 operators, depending on your operations. So going into another technique, automation technique, this would be where your robot is physically moving the part and through your process or dispensing, maybe glue or grease, doing a robotic screw driving, welding, or riveting. Extol does all those, but the reason that you might use something like this is when you need to move the part physically, and you need to go through a lot of processes and you don't want to manually do it, the robot would be good for that to present the part to different processes. We also use robots for smaller components when you have maybe, say, clips or screw driving, as we mentioned here. You can auto install those, minimize your operator time of loading clips onto clip drivers, and auto install them with a robot. And you can see a few here on the top left one. We're actually doing a push nut install on there with the robot, and we're also infrastaking, so you're kind of welding with the robot as well. So that's one way of doing it. You also have in the top right hand corner, you have a robotic grease application. So we're applying grease with that robot. Bottom left hand corner is an example of a Cartesian robot screwdriver. And Cartesian robot would just be a more cost-effective robot if everything's on the same plane. And then your wheel liner down on the bottom right-hand corner, we actually have a left-hand and right-hand station. As you can see, kind of in the concept. The concept on the way bottom right-hand corner was generated by Manufacturing Solutions Center, and that's what you would get during the quoting phase if it's a pretty in-depth concept to help you understand what we're quoting. But you can see the 2 robots. The one robot in the middle, the bigger one, goes between station to station and welds the NVH pad onto the wheel liner. And then you have the smaller robot actually installing rivets, plastic rivets, to attach a component onto that wheel liner. The reason the left-hand side is an indexer would be actually for cycle time, because we had that second component with the rivets. We had to have the operator loading while the robot was doing its work. So, and that was all generated during Manufacturing Solutions. Next would be bowl feeding walking beam equipment. So bowl feeding is essentially used to take small components and singulate them. So that's usually used with clip drivers, as we were mentioning. That push nut that we mentioned on the previous one, that had a bowl feeder to singulate those push nuts into one, so the robot could pick it up and install it. So that's what bowl feeders are usually for, smaller components that you want to auto feed. And then a walking beam would be the parts actually move from station to station all simultaneously, and it's like a pick and place that picks up all stations at once and then moves to the next station. And that's usually used for that's usually used for operations that you need to have different nests on. Specifically on the left-hand side, we were weighing the component, and you don't want to have, you don't want to do a pick up the nest and weigh it, because those nests can be different weights depending on the tolerances. So we just dropped it into a weigh nest. That way we are able to calibrate it a lot easier. And it's a lot better solution that way. And that was generated during Manufacturing Solutions as well. You also, the benefit of it is you can flip the part and have a separate nest on the next station. Flip it, go to the next station, and be able to do your work on the opposite side of the part. And that's what that right-hand one does during the process. So these do a lot of different, the left-hand one does the weighing, as I was mentioning. You actually auto screw driving a component that's getting introduced by the bowl feeder, and that's the brown portion back there. That's getting introduced by that bowl feeder, and we're auto screw driving it together, and then we're laser engraving. And then on the right hand side, you can see that we're doing auto screw drive as well, flipping the part, leak testing it, and ultrasonically welding a smaller component. And then if you combine a certain number of those techniques and use it to fully automate the line, you'll just get into fully automated turnkey equipment. And when this is used is for very high volumes or when you don't want to have really any operator interface with the line. So this would be the operator bulk feeding components into the automation cell, and then it comes out as a fully assembled product, whether it's packed or bulk outgoing. So bulk as in going into bins, just kind of a bulk bin. So on the top left-hand corner, we're actually doing a hot plate welding process for a battery upper and lower, and you can see the robot placing the robot picks up the upper and places it into the welding equipment. The conveyor comes in and will allow for the lower to come into the welder. And these are all automated from the previous process. So there's minimal interaction with the operators. And then it comes out as a fully welded assembly. On the top right-hand corner, you have we're doing a infrastake and threaded insert install on a pretty large part bed rail. And we're destacking them to go to the robot, that larger robot. The robot places it into the machine back there, and then there's one robot in the back corner that actually places all your threaded inserts into the part, and then we drive it at the station. Then once it's done, that bigger robot in the middle places it onto an outgoing conveyor. On the bottom left-hand corner, you have a pretty large cell that is doing a medical reservoir assembly. And what those angled conveyors are, those are for trays to go in. So you're bulk feeding in with trays that get stacked up. And then we're pick and placing those fed components. We're doing that in the first two stations. The third station, we're actually robotically installing a vent with a bowl feeder. So that was a smaller component that we bowl fed in. And then you're hot plate welding in the next station, the upper to lower. The next station, you're bowl feeding another component and you're placing that with a robot. The last station on this first dial actually picks and places all the parts onto a leak tester dial that has multiple stations for cycle time. And then we leak test all those components and they get bulk fed out. In the bottom right-hand corner, you have a gas tank filter assembly cell that takes pretty much the gas tank filter fiber. It was a fiber filter. You can see in the bottom right-hand corner the pink rolls. We're laser cutting it, ionizing it, cleaning it, and then we're also assembling the gasket, plunger, and cover to it as well. So all those were a lot of automation techniques, different examples that we've had in the recent past, that Extol's had in the recent past of automation techniques and how to skin a cat from an automation standpoint. And as you can see, we've had a decent amount of experience with all those fields. Now we can get into the custom operation experience. So this would be what the machine's actually doing, whether it's hot plate welding components together, whether it's screw driving components together. We have a lot of experience with that, and these are a lot of the operations that we see common and split into about 4 different categories is what I'm thinking. So you got the mold side operations. So we do a lot of degating there, a lot of drilling, a lot of end of arm tools for molds and all that type of stuff next to the mold. And then you also got the plastic assembly. So the screw driving, as I said, the snap assembly and the clip driving, and the limiter driving. And there's a couple examples there of a snap and a clip driver right next to that. And then above that, you have a degator and an end of arm example too. And then we obviously have plastics joining experience because we have a lot of technologies within that field. So we're pretty good at integrating, staking equipment, hot plate welding, and we're not afraid, and laser welding, all that type of stuff, having machines, custom machines for that. And we're not afraid to have ultrasonic welding as well. We do that a lot as well when deemed fit. So, and then you have part mark testing and part testing. So leak testers, light testers, laser engravers, and then dot peen matrix, maybe, things like that. we do that as well. And you can see a couple of those examples to the right, a dot peen barcode marker, 2D barcode we were doing with a dot peen there. And then on the right-hand side, we were doing the end-of-line tester there, and hot stamp. And then above those, you can see a custom hot plate welder, an ultrasonic machine, and then also an infraguide technology integrated into a custom machine. So I wanted to go into interchangeability and flexible futures. A lot of people are pushing for a flexible future because it saves cost in the end, right? It saves cost down the road. So we've actually implemented a lot of flexibility with every different type of automation technique. So whether it's a manual machine, like the left-hand side, we've done quick tool change on those. Whether it's an automatic quick tool change seen in the middle, you can see those tools actually spinning, and those spin because it's going between different versions of parts. So automatic quick tool change. And then you also have, when it comes to fully automated lines, if you're having the robot place parts into machines, we've done it where you can have flexible machine line or flexible automation cells where you can take that machine out of the automation cell and then close a door, and the automation can still run. And then you can also run that machine manually off the line, as you can see kind of in the photo below. That's a picture of that machine off the line, and that can be totally ran like an operator will just place in the part and manually run it. So that's pretty huge for downtime. You're not going to get any downtime if a robot goes down, or if maybe this machine goes down and you need to maintain it. You're not going to get downtime for the automation side of things too. So we see a lot of products come through our facility every day, and these are the three main categories. Most of these parts most of these assemblies we've actually touched at least a component in here. So we see a lot of automotive, and we also see a decent amount of medical and consumer products as well. And we've worked on all four of those products and work on a lot of other medical and consumer products as well. But those are our three main categories that we usually see from a product standpoint. So why Extol automation, right? So what sets us apart? We have a dedicated team that thinks custom day in and day out. You have dedicated design engineers, dedicated controls engineers, dedicated project managers for your specific project. And so they think it day in and day out. They know what they're doing. We have that experience, that 35 years of experience, over 35 years of experience. So we've pretty much seen every automation technique, and we've seen just about every operation after the mold for a plastic part or anything that has been thought to be plastic. And then we have outstanding support. Bob mentioned it. We support you through production life. So whether it's spare parts, whether something goes down on the machine, warranty, or you're getting ready for production, we're going to support you through that. And we're not going to leave you hanging and ship you a machine that doesn't necessarily work or has kinks. And then we also have the Manufacturing Solutions Center, and Bob touched on what we do, and we help you out with figuring out the concept, figuring out what's going to be the most cost-effective solution for you that will also give you what you need for requirements. So with that, I wanted to thank all you guys for joining. I appreciate the time, and hopefully you learned something new today. I want to also reach out to you guys. If you guys want to learn more, you can go to our site. You can also contact Extol, and we're more than willing to do a on-site webinar or another virtual webinar that focuses on a little bit more of what you're looking for if you want to dive in deeper on one of these areas. So on our website, you can find example videos. You can request a quote, and you can just talk with us. So thank you guys, and with that, I'll give it back to Jason.
Thank you, Rodney, and thank you for such a great presentation. If you have any questions and you'd like to get those in, now is the time to type those in and send those our way. We're happy to answer those. while you guys are doing that, I want to highlight that we will be emailing everybody who registered and who attended, and sending out a copy of this presentation, both PDF format and then a video recording of the event today. I just want to apologize that the webcam wasn't working. A little bit of a technical glitch on our end, but I think hopefully you were able to get everything out of it that you needed to get out of it with the slides on the screen. We'll be sending that email out probably either later today or tomorrow. So one of the questions that we got here is, when does it make sense to have interchangeable tooling? So when is it like cost effective? When does it make feasible sense?
Yeah, that's a good question. Some of the key things to look at when you're looking at is interchangeable tooling the right choice for me or not would be one thing would be the technology that you're using, also the footprint of the part that you're trying to utilize compared to other footprints of the other parts that you're trying to utilize. Typically, we utilize interchangeable tooling when there's a low volume and you want to change out parts and be able to change out, and you save capital by doing that, and all you're doing is paying for tooling for each of the different iterations. Or if you know that in the future you'll be getting similar products, so when one is phasing out, the next one, all you would really need to do is purchase the tooling side of things, and the capital would already be there for that particular tool. If you look at it from a cost standpoint, going with a flexible interchangeable tooling roughly adds, it depends on the technology, but I would estimate between 20 to 30% on the initial purchase. But typically that's paid for by the second go around of tooling, because you're no longer purchasing capital, you're just purchasing the tool. So you have the savings from that kind of pays for the increase that you see initially.
Thank you. So that's all the questions that we have. If there's any other questions that you have burning in your mind that you want to ask, maybe outside of this forum, when you get the email that has the copy of the presentation, feel free to reply to that and ask your question, or you can always reach out to us at sales@extolinc.com if you don't know one of our personal email addresses individually, and we have contact forms on our website as well. So love to get in touch with you, and thank you all for joining, and have a great afternoon. Thanks.